Welcome. So today we're diving into a pretty radical new idea in air defense, an idea that completely swaps out explosions for entanglement. We're going to explore how a super high-tech net could basically create a sky shield against modern threats. Let's get right into it.
All right, to really get what's going on, you have to look at the core problem in air defense today, and honestly, this slide says it all. On one side, you have a $4 million Patriot missile. On the other, a $20,000 Shahed drone. I mean, you can see it right away. The economics here are just completely, totally upside down. Think about it. Firing that $4 million missile to take down something that costs as much as a used car, well, it's just not a winning strategy in the long run. This massive imbalance creates what military strategists call a cost asymmetric problem. And what that really means is that defending yourself becomes so wildly expensive, you could literally go broke just by being successful. But what if there was a totally different way to think about this? A proposal from a couple of years back poses this exact question, and the solution sounds, well, more like something out of science fiction than a military white paper. What if, instead of a bigger explosion, the answer was a better trap? The whole concept is called the Kinetic Interdiction Net System, or KINS for short. So let's break down how this high-tech spiderweb is supposed to work. Basically, it's a reusable system where these huge, heavy-lift drones deploy a massive net up in the sky. And the goal isn't to blow the target up, but to get what's called a mission kill. You just tangle it up so it can't fly anymore. So how does this actually play out in a real scenario? Let's walk through the anatomy of an intercept. And for our target, let's use a really common threat, something like the Shahed 136 drone. It's really like a five-step dance of tech and physics. It all starts with step 1, detection. An AWACS, that's one of those big radar planes, or maybe a ground station, gets a lock on the drone and sends the data over. Step 2, positioning. A couple of heavy-lift drones book it to the predicted intercept point. Now for the really crucial part. Step 3, terminal homing. In the last 5 seconds, their own onboard sensors take over and make these tiny micro-adjustments. And then, step 4, impact. The target slams into a special 20-meter breakaway panel in the net. Which brings us to the final step, step 5, mission kill, as that detached piece of net just completely tangles up the drone's propellers and wings. And this, right here, is the beauty of the mission kill. The expensive drones and the main part of the net, they just stay up there, totally fine, ready for the next target. Meanwhile, that captured drone, all tangled up in a pretty cheap piece of net, becomes aerodynamically useless and just falls out of the sky. Mission over. No big boom, just elegant physics. Now, I know what you're probably thinking. This all sounds great in theory, but it really comes down to a simple, practical engineering question. Can a couple of drones really lift a net that's big enough and strong enough to actually stop something like a cruise missile? And believe it or not, the answer boils down to a single, surprisingly elegant number that came out of all the engineering analysis. Let's say you've got a standard net height of 100 meters. For every single kilogram of payload a drone can carry, it can support exactly 0.5348 meters of net width. It's a constant, it's predictable, the math just works. Okay, so let's take that number and apply it to some drones that are actually out there. You can see on this table, a pretty standard drone, like the Mallory T1400, can carry a 200-kilogram payload. So you do the math, 200 times 0.5348, and boom, that gives you a net width of 107 meters. So if you have two of them working together, you easily create that 200-meter-wide aerial barrier we were talking about. And this, right here, this is the bottom line. This is why it's such a big deal. KINS completely flips the entire economic equation of air defense. I mean, just look at this chart. A $4 million Patriot intercept versus a $20,000 KINS intercept. That's a 99% cost reduction. It's not an improvement. It's a whole different ballgame. So why does this all matter? Well, first, it completely flips that cost asymmetric problem on its head. It means you can actually afford to protect critical infrastructure. You know, things like power plants and hospitals. It means you save those multi-million-dollar missiles for the truly scary high-end threats. And because the drones are reusable, you're not just burning through a limited supply of missiles. You're creating a defense that is truly sustainable. All of this leaves us with a pretty provocative thought, doesn't it? For decades, air defense has basically been a race for a bigger, a faster, a more precise explosion. But maybe, just maybe, the truly revolutionary path forward is something quieter, cheaper, and a whole lot cleverer.
Perhaps the future of defending our skies depends less on a bigger bang and more on a better net.